sensitive. You want to make sure all the doors are closed when you're weighing your sample, because air currents can actually change the reading of your sample. So make sure everything's covered when you're actually weighing it. Before you weigh anything out, you need to make sure that it's clean and dry on the inside. And ours is clean and dry. Before you weigh anything in your balance, you want to tar it. So as you can see, there's some numbers on my reading right now. And if you tar it, it'll go back to 0. Now, I'm going to weigh our beaker first to get the mass. This will be your initial mass. You want to do this because you actually just want to get the mass of the water. And so after that, you're going to get the mass of the two and subtract. But here we go. I'm going to gently open the door, place my beaker inside, close the door. So the mass is 66.299. I'm going to take a look at that. And then I'm going to write it down here. And that's my mass initial. Now I'm going to take the beaker out, pour in a random sample. Okay. And my sample is about 50 milliliters from this side. So I'm going to write that down. Here in my mass, in my volume final, is 50 milliliters. My volume initial was just 0 because we didn't have anything in our beaker. Now I'm going to weigh this again. Wait for the reading to stop. And it says 108.325.
My name is Jayla, and I will be measuring the density of water. You have your balance. And one external factor that could affect your results would be leaning on the table or pushing against the table, because it can add extra mass to your results. And also, it's important to use the same balance so your answers stay consistent, because each balance has like certain amount of air that's in it that keeps it constant. So, first, you're going to zero out your balance. As you can see, it's on 0. Everything's closed, so no air is getting inside. And then you're going to measure the beaker, the mass of the beaker. As you can see, the mass of the beaker is 66.299. And you will record it in your table. Now you take the beaker out, close it back so no air gets in, and you're going to measure out a random sample of water. As you can see, this is measured at 70 milliliters.
This isn't very clear.
And now you go to your table and record it in your volume final, because your volume initial is 0 because there's nothing in the beaker. Now, 6, 2, 1.
Alright, now we take the volume addition.
And you record it in your table.
Subtract it.
And now, to find the final mass, you take the initial mass and subtract it from the mass of the water and the beaker. So you take 79.890, which was for the first measurement of 20 milliliters of water, and subtract the mass of the beaker, which is 66.299, and you get as your mass of just the water 13.591 grams. And you're going to do that for each calculation.
Okay, now we're going to find the density of water using a graduated cylinder. First, I'm going to tar out the balance. Just going to press this. Let me press it again. Okay. And since this is bigger than the inside of the balance, we're just going to move this and place it in here to weigh it. And then we're going to place this back over. Since we're not getting an accurate reading of this graduated cylinder, we're going to use a smaller one. So, I'm just going to take this graduated cylinder, we're going to place this back on there, because I think that's why we weren't getting an accurate reading. I'm going to tar this out again. Okay, so that's 0. Now I'm going to open the door, place my graduated cylinder inside, close the door. Okay, and here we go at an accurate reading of 25.2599. Sorry, I didn't want to make a mistake. So I'm just going to record that on my graph right here, 25.259. Okay. Go.
Okay. So, when you're using a graduated cylinder, to measure how much liquid is in it, you have to use the meniscus. Now, the meniscus is so oxygen is very electronegative. So, it always wants to get the density from other atoms. And oxygen is attracted to hydrogen, and they are so pulled towards each other that it creates a seal. Now, when you put the water in a glass, the particles from the glass and the water become attracted to each other, and it forms a concave shape. And when you have the concave shape, to read it, you have to read the bottom of the curve to get the exact reading.
Now you're gonna pour some solution into the graduated cylinder. Just a random amount, doesn't matter. Okay, I got a lot in this one. You're gonna read it from the bottom of the meniscus, and it looks like it's 9.1. You're gonna look. Stop it, not for Wendy. What did it look like?
No, it does to me, not on the video though, because it's kind of hard to see. But
okay, we're gonna wait for our reading to stabilize. It stabilized at 34.2. Now it's moving again. 2313 is what we'll say. 34.2313. I'm going to record that in the recorded that in my notebook.
so, to start the experiment, you take your graduated cylinder, you zero out your balance, and you open open up from the side, put the graduated cylinder in, and the reading is 25.288. 8.
9, 8, whatever.
So we're going to record the initial mass as 25.2829 grams for the graduated cylinder. And now you take it out. Okay. So now you want to use your graduated cylinder to get the amount of the water. So you're going to pour a random sample in and wait, and then measure at the meniscus. And the sample is 4.9 milliliters. We're going to record it in your chart as the final volume.
The mass of the original thing I got was 96.058.
And then you are going to open your balance, place it inside, make sure everything is closed, and record the number as 30.1220. Record it in your chart as the final mass. So I'm going to do subtraction.
If you want, yeah.
And now that you have all your numbers, to find the mass of the water, you take the final mass, which is for your first reading, which is mine was 5.1 milliliters. You take it and you subtract 30.3668 from the initial mass of the graduated cylinder, which is 25.2829. Give that, and your mass of your water is 5.0839 grams.
All right. Yeah. Well, now, I must admit, I can't explain any of these thoughts racing through my brain. It's true. Baby, I'm howling for you. Alright, there's something wrong with this plot. The actors here have not got a clue. Baby, I'm howling for you. Mockingbird, can't you see? Little girl's got a hold on me like glue. Baby, I'm howling for you. Yeah. Throw the ball to the stick, swing and miss enough.